again more about parallel lines. You thought we had done that already. A little more. Not too much, a little bit more. Works together really well. I think it will just reinforce what you already know. So let's take a look. Okay, I gave you an example over here that I wanted to work through with you. This example up here, it says that we have two lines that are parallel. That would be L and M. Okay, I didn't state it, but line T is a transversal and line S is also a transversal. Now, these two lines are parallel. You can see that it's given and you can see that it's marked. Two things that you look for. And I think it's helpful if you mark it on both ends sometime. All right, I'll show you why. If I want to find all the angles in this diagram, I can, but I got to be careful. The more lines that come into a picture or segments, the more careful I have to be. So let's take a look. This and this are parallel. No guessing. It's definitely parallel. So all of my theorems and postulates that we just went through are true because these are parallel. All of them said if two lines are parallel. So I know corresponding angles are congruent, so I know that would be 50 also. I know that, I know vertical, so let's go and put those in because that's easy. Verticals are always nice and easy to pop in. Then I know linear pairs, so 50 and this would be 130, and 50 another linear pair situation, a vertical angle, and you see just how quickly all that fits together, which is great. Then we look over here, and this is where I want you to be careful. All right? This is 40, so you know that that angle is 40 because it's vertical and they have to be. Now, look right here. Remember how I said a while ago that same side interior angles are supplementary, meaning they add 180, and these don't, they add to 90. So does that bother you? Do you see any reason why they don't add up to 180? Remember that all of those, that the postulate with corresponding angles and all of the theorems that we had in the previous track were conditional statements, and they all started if two lines are parallel, then all those angles are congruent and supplementary. These two lines are parallel, so I could use those two lines with that transversal, and I could say, oh yeah, that all works out. These two lines on the other end, of course, are still parallel, and on this transversal, then try not to look over here at all. You might even want to get a piece of paper and cover that up so your thinking doesn't get muddled with it. But when you're looking at these four angles and these four angles, you want to be running up and down like this transversal is a track. Okay, so your same side interiors are on the same side of a transversal. So you can't mix up these angles with these angles because I have two different transversals. And because line T and line S are not parallel. So be careful, careful, careful. Always put down what you know for sure first, and then really, really carefully go from there to think through the rest of it and check your work. So if that was 40 given, then that was definitely 40 because it's a vertical angle. And if that's 40 and that's a linear pair, then you know that would be 140, and then that would be 140 because of vertical angles again. Now, again, this is still the same set of parallel lines, different transversal. So run up and down that transversal to find your corresponding angles. They go with their own transversal. So if this is 140, then this one matches. There's nothing to do with these over here. That's a different transversal. Okay, and so if that's 40, then that's 40, and you can fill in the rest of this easily with your other theorems there with vertical angles and so forth. So I just want to caution you, the more lines that creep into the drawing, to make sure, number one, that you have identified correctly your parallel lines and the transversal one at a time. Don't jump from one transversal to another if they are not parallel. So be careful about that. Here's another situation. I'm trying to get you to see and to get comfortable with parallel lines and segments being inside figures sometime. And they're not always just going to be out there by themselves, as we already said. So here's a triangle. Here's a segment that's given, by the way the figure is marked, to be parallel to this side over here of the triangle. So that's parallel. Now look, I've got this serving as a transversal, it just doesn't cut all the way through. And I've got this serving as a different transversal. Remember what I said, run up and down the same transversal to apply your theorems and look for your corresponding angles. So I'm not going to look at these angles here. This one, and this one have not anything to do with those at this point. I'm just looking at parallel lines and the one transversal and going up and down it. Then I'll get over there in a minute. Okay, so this is 80, and here are my parallel lines, and it might actually help you to, I don't know, mark it a little bit closer to the site, so that just might give you a little more of a visual. So that's a parallel, that's a parallel, that's a transversal. So what is true now about this angle and that angle? And think about what they're called, because they are on the same side of the transversal, aren't they? Yeah, so they're called same side interiors or consecutive interiors, and they're supplementary. Yes, so that's 80, that one is 100. Alrighty? Now that we're done with those, we're finished, cover them up, don't look at them, go to your other transversal. You've still got the same set of parallel lines, a different transversal, so run up and down that track, that transversal, to find your corresponding angles. So here's 40, so this would be 40, because it would be corresponding, and then this one would have to be 140, because those are a linear pair. And I left this one off. If that was 80, this one would have to be, if that was 100, this would have to be 80. So that is just another way that you will see parallel. So you want to be looking for them. You have to be very alert in geometry. It doesn't come and grab you like you may think it is, like a monster and it's just going to get you or something, but it really doesn't. It's just there. You have to go and get it. You have to be alert so that you see parallel lines, but yet your mind says angles, 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 and be careful of the transversal. And so forth all the way through the class. So I want you to be looking for vertical angles. Let them jump out at you. You go get them. Vertical angles are congruent. They're my friend. To be looking for linear pairs. Don't let them sneak up on you. You go and find them. You go and look for parallel lines. Don't mess up a problem and then go, oh, I didn't even see those parallel lines. You are on the lookout for them. And once you find them, you have all their secrets at your disposal. So that's a great thing. So I think that we will conclude our, no, there is one more thing I want to put in this part right now. I want to address what I've written up here, and it says converses are true. You know, when we talked about what a converse is, we said take a conditional statement, if, then, could be if anything, then anything, and switch them. Switch the if and the then. And sometimes that will give you another true statement, and sometimes it won't. At any rate, it will be called the converse. So we're going to look at the converse of the statements that we just used. The first one, again, is a postulate, and it says, if corresponding, and I'm going to abbreviate if you'll allow me to, if corresponding angles are congruent, then lines are, parallel. And you might be saying, didn't we just do that? Well, no. What we just did was the converse. We had a postulate given to us that said, if two lines are parallel, then the corresponding angle is congruent. And that was wonderful. And this one says, hey, this is even better. We can take the converse and it's still true. We can say if corresponding angle is congruent, flip, then the lines are automatically parallel, and that's so good to know. And every one of those that we just did, all those theorems before that we just reasoned our way through, all of those converses are true also. So in a nutshell, we have this to be true. If alternate interior angles are congruent, then lines are parallel. Yay! The more we know, the better. If alternate exterior angles are congruent, you say it, then, and you're right, lines are parallel. So exciting, isn't it? And there's one more, and it says, if same side interiors, you have to abbreviate. Well, you don't have to. I have to, because it's just so much, it's such a bother. It bogs down your thinking. So you got to do what your teacher says. If he or she wants you to write it all out, do that. If same side interiors, or maybe you're calling them consecutive interiors, doesn't matter, but if those angles are supplementary, if they're supplementary, then lines are also parallel. So goodness, it's so easy to prove lines are parallel. Any of that will do it for us. Any of that tells us. So the more we know, the easier it is. Truly. So you're really getting your bank of knowledge, your list of postulates and theorems really is getting quite extensive now. Whatever textbook that you're using, and this DVD is designed to go with any textbook of just a course of geometry. Most of the time in the back of the textbooks they have a list of the postulates and theorems, and if not, certainly they have them scattered throughout the text and highlighted in bold, and you'll find every one of them there in sophisticated language. And your challenge is to understand the meaning, not memorize, although you have to know them. There's a difference in memorizing and knowing. You have to know them, and you have to be able to deal with the sophisticated language. But you have to know in your heart, in your gut, in your brain, in your mind what they mean, and that's what we are working so diligently on. So we've got a really good foothold in our parallel study right now, and we have a few loose ends. I have a track at the very end of this tape called loose ends, things that I wanted to make sure get in there, but I don't want to clutter our thinking with it right now. So we're going to let this be it for the moment, and I'll see you again tomorrow. Have a great day. I really hope